Okay, so this is the second part on the if-then statement video. Now, as a refresher, what we did in the previous video was we were able to construct a truth table for the if-then statement, and we showed that this way of constructing it is the objectively correct way. Now, there's a lot more to discuss. One thing that we're going to start with is if I were to draw the truth table for not A or B, then we will find that the two columns over here and over here are exactly the same. Now this is not too hard to construct, so let's just do it quickly. This guy is F, T, F, T, and since the third row is where both these guys are false, then third row should be false, while the rest have at least one truth in them, so the rest can be considered as true. Alright, and yeah, so you can see both of these guys are indeed equivalent. Now, this is a problem. What does this mean? This means that if I were to construct an English sentence out of this structure, and if I were to do the same thing with this structure, then I'll end up with two different sentences that convey the same meaning. And this could be a bit problematic, as I will show you. So what was our first statement? Our first statement is if A happens, then B happens. And our second statement is not A or B. So for convenience purposes, let's use the same meaning that we assigned in the previous video. So the first one would mean if I went to the store, then I would get some milk. So the second one means either I went to the store or I will get some milk. Now at first glance, those two sentences that I just said, it isn't obvious that they convey the same meaning. In fact, some of you might argue that they don't convey the same meaning at all, just because they feel so different from one another. And that's a problem because this means that our truth table that we constructed might not be true in the first place. But don't worry, I'm going to try to convey to you that this statement, along with this statement, are equivalent. They do indeed convey the same meaning. Now, since it's pretty obvious and clear what statement 1 is trying to tell us, let's focus more on statement number 2. So, what is statement number 2 trying to tell us? Well, I hope you can agree with me that statement number 2 essentially means that not A being false and not B, and B being false is impossible. Now, why can I interpret it in this way? How is this valid? Well, let's take a look at what statement number 2 is trying to say. Either I didn't go to the store or I got some eggs. So what does this mean? It means that at least one of them has to be true, because either this happened or that happened. So either one of them has to be true. And you can't say that both of them are false, because it contradicts the meaning that I'm trying to convey. I'm trying to tell you that either this happened or that happened. So if you say that both of them are false, that would be impossible. So this is why this sentence that I wrote down over here is a valid interpretation. Now let's break this down even further. What is B being false? Well, B means I'll go get some milk. So if that is false, then we can just rewrite it as saying not get milk. Alright, what is not A being false? So what is not A? A is going to the store, so not A is not going to the store. So not going to the store is false. So if that is false, that means that we do end up going to the store, right? Because the two negatives cancel out to form a positive. It's like saying I did not die. So that means I'm still alive. So same concept there. In the end, we have going to the store and not getting milk is impossible. This is what statement number 2 is trying to tell us, or rather an alternate meaning that we came up with. And it is much easier to see that this is equivalent to this guy. Why? Because think for a moment. Because if we're going to the store and not getting milk is impossible, that would mean that I am going to the store with the intention of getting some milk. Now notice that this is exactly the same as what number 1 is trying to tell us. If I go to the store, then I'll get some milk. Exactly the same. So we started with statement number 2 and we changed things little by little, and we ended up with statement number 1. In fact, both of these convey the same meaning, and it just takes some work to deconstruct all of that in a way that we can understand. Alright, so what have we found out? We found out that if A, then B is equivalent to not A or B. And it also turns out that this guy is also equivalent to this statement over here. And again, it's pretty easy to show that these two guys are equivalent to one another. Just do the same thing as I did before. Construct a truth table, make sentences out of these guys, and show that they have the same meaning. So I won't do that again, because I already gave you an example and that's plenty enough already. What else is important to know? This guy is not equal to this guy. This means that the order does indeed matter, and it's pretty intuitive to understand why, because this means if I go to the store, then I'll get some milk, and this guy over here means if I get some milk, then I'll go to the store. Obviously, these two are not equal to one another. Alright, one last thing before we end the video. What if we have the statement that looks like this? What does this mean? If A happens, then B happens, and if B happens, then A happens. This structure will come up a lot in maths, so much so that we invent a new symbol to illustrate this entire concept, and that is the double arrow sign. This means if A happens, then B happens. Likewise, if B happens, then A happens as well. So these two symbols or statements are interconnected with one another, as in if one of them happens, that means we know that the other one happens, and if the other one happens, we know that this one happens as well. And these relationships between different statements are prevalent in mathematics. Since they're so prevalent, let's go through the structure of the truth table for this guy. Alright, so we know that this is TTFT, and like I said, this guy is not equal to this guy. It has a different truth table. So this guy is TTTF, and it's not too difficult to construct the truth table for that. All we have to do is switch B with A here, and likewise we just have to switch B with A here as well. And since these two are equivalent, we can construct the truth table for this guy, which we already know how to do. And we will find that it will be exactly the same as this one over here. How do we construct the truth table for this one? Well, simple. This is an AND statement, meaning only the first two rows are selected, while we can put F on the last two. So this is it. This is how to construct the truth table for a biconditional statement. That's what this guy is called. We'll call it a break there for this video.